Hi there, I'm Bhavish, and in this video we are going to look at a simple calculator program created in Java and running on AS400, which is also linked to a command which triggers the Java program and passes all the required parameters. So let's begin. So as we have seen in our previous videos, we have created a command, we have created a CL program, and we have also created Java, and we have also passed in the parameters to the Java program. So in this video, we are going to review a calculator program which I have created for the demo for this video recording. I did try to write the program while the recording was on, and it took me exceptionally long time to write a simple Java program because I'm not used to writing Java anymore. So let's just review what program I've written and already tested. Let's begin. So first things first, we have to we need three artifacts. We need a CL program, we need a CMD program, and we need a Java program to execute the logic. Let's start with the entrance point, that is the command. So we created this source for the command. On the first line, we give the name of the command, that is CMD calculator, and we accept three parameters. We have kept the type as character for now. We could have gone with double for accepting numbers, but we have just kept in characters for simplicity. So we accept first number, second number, and an operator in the middle. So we expect an output like this. 4d5 is nothing but 4 division 5, 4 divided by 5. Now you would think, why didn't I use a star or a slash for division, or the actual sign of the plus or minus? So it turns out that you cannot use plus as an input value because that is already reserved in AS400 command. So I had to come up with alphabets for addition, subtraction, multiplication, and division. So that is what this example is going to showcase. So in this command source, what we have is we have three parameters that we are accepting. Length is a random length. So the length of the number is 5 and length of the operator is 1. That is what we need. We have created three variables, param1, param2, and param3, and we are accepting the three variables. So that's it for the command. Then you need a CL program to actually call the Java program and to pass the values to the Java program. So I've taken reference to the previous video where we have passed in the values to the Java program, where we created the command for the first time. So what we are going to do here is the same thing. We are accepting three values as the parameter for the CL program. These three parameter values are coming from the CMD that we just saw, param1, param2, and param3. So PGM and end PGM, the boilerplate code for the CL program. We are accepting the three parameters into the CL program. You also have to declare all these variables to retain the values and to be able to use these variables in the CL program. We have a command string, which is of an arbitrary length of 50. You have the concatenated length to create a string, which is going to call the Java program. So when you execute a Java program like so on the bash shell or the PAC shell, you have to execute it like this, like a normal Java program. So you have to construct this string in your CL. So the first variable is going to be the name of the program, with Java, name of the program, a space, and then you have to specify the arguments. So that is what we are doing here. We are declaring the variable to store the first part. Then these arguments we are concatenating and we are adding a space in between. We have also created a space variable and we are concatenating it together to create a string like this. And that string is then executed with qsh cmd, which actually calls the Java program. All right, now let's go to the Java program. We will go through the program that I just wrote. So we have created a new Java program in the IFS home directory of the AS400. So as you know, we are using the IBMI extension for Visual Studio Code, and we have actually connected to the pub 400 AS400 server. So we have created a new source file of Java where the class name calculator is written over here. We've created a new calculator.java file the boilerplate code for Java, public static void main string args, the arguments that we are going to pass the Java program. For example, over here, 4 divide pi are going to come in this string array. Then we are just displaying what input we have received. So in this example, where we are doing 4 divide pi. So here the length of the args is 3 because we have passed in 3 parameters, and it is just then printing the 3 parameters that we have passed, and then it goes on to calculate the answer. So 4 divided by 5 is 0.8. So then we have validations. So for validations, we have built in a separate method in Java to validate our input. So if you scroll down in the Java program and look at public static boolean validate input string args, we have a set of validations where we are checking a lot of different things. We are checking if the length of the arguments is less than 3 or greater than 3. We need exactly 3 arguments. If the length of the arguments is less than 3, we are giving a validation error that we at least need 3 parameters, and which are those 3 parameters. And we are returning false. That is, it is not a valid input. If the length of the arguments is greater than 3, then we are giving a validation error that the only 3 parameters are allowed, no more than 3. And we are then returning a false response back. We are also checking if the first and the third argument, that is in the sense of Java, the 0th element and the second index element should be numbers. So this 4 and 5 should be numbers. So we do not need them to be integers. There can be decimal numbers also, but they should be numbers. So to check if it is a number, we have created an isNumeric method. What isNumeric does is it checks, it accepts the string, and it tries to parse it with double.parse double. It accepts the string, and if the parsing is successful without any exception, it will return true. That is, that it is a number. If the parse double fails, it is going to return an exception that the parsing has failed and it is not a number. So we have written logic if isNumeric is false or this variable's isNumeric method is false. If either of these is false, we are going to say that both the arguments should be numeric. Either one or both of them are not numeric. Then we have a last validation where we are checking if the operator that we are passing, B, A, S, M, or D, whether this operator is actually the correct operator to be used. So A is going to be addition, S is subtraction, M is multiplication, and D is division. So these are supposed to be the valid operand values. If they are not, then we are giving a validation error in the output, and we are returning false. So all the places where the validation fails, we are returning false. If all these validations are successful, the last return true is going to be executed as true, and the return value for this method is going to be true. That is, the input is valid. So we have created a simple method to validate our input. Then we go on to the actual logic of the calculator, where we create two double variables by parsing in the string of the 0th index and parsing the string of the second index. So we have double.parse double to convert the string, because whatever input we are getting is in the form of string, and we need to convert that to a double. That is a floating point number or a number with a dot. That is a double. And the answer is also a double. So we have declared and initialized it to be 0 initially. And we have written a switch statement which checks the arguments. It checks in the operator. That is the second argument. In Java terms, it is the first index, the index in between, or the argument in between. So there is a switch statement which checks if it is equal to A. Then we are going to add with answer is first number plus second number, and we are going to print it out on the screen. Let's subtract. We are going to subtract. M is for multiplication, D is for division, and the default is a validation error which will say that the second argument must be an operator, A, S, M, or D, and it is going to return back. So this is our Java program for a simple calculator where we do input validations and we actually perform the operation that is required by the user. So we have created all the source codes. we can go ahead and compile them. Within Visual Studio Code, we can submit Control E, and it is going to list down the list of valid commands. So CRT-CMD for a command source, it will create a string of the command that is going to execute CRT-CMD. If you press enter, it is going to compile the command. It has compiled successfully. We also need to compile our CL source code. So again, Control E and create CLP and enter. We have compiled our CL program. And for Java program compilation, we need to be in the same IFS directory where the Java program exists. So if I do ls, it says calculator.java is in the same directory. You can compile it with javac calculator.java. So it has returned back with a blank, which means that the compilation is successful. We will demonstrate running of the program now. So calculator is the command. 4. We got our 3 parameters: first number, an operator in between, and the second number as input. Let's try with different values. So 45.6 addition 1.0. The answer, the length of the RX is 3. 45 plus 6 addition 1.0. The answer is 46.6. Correct. Let's try some other operations. Let's do subtraction. So the second iteration, our inputs are 45.6, subtract 1.0. The answer is 44.6. And that is also correct. Let us also try with multiplication with m, and we'll give it as 0.5. So it is actually going to do divide by half. So 45.6 multiplied by 0.5 is nothing but dividing it by 2. That is 22.8. Also try division once. So divide, and we are going to divide it by, let's say we are dividing by the same number, 0.5. What we are getting is a double of it. 45.6 divided by 0.5 is 91.2. So this is it. We have created a command in AS400, which is going to execute a Java program, which is also running on AS400. And we have also done basic validations of the input. We have taken in the command from a command source. We have moved in the values to a CL program. We have passed on the values to a Java program, and the Java program is actually doing the arithmetic for us. So this is only for demonstration purposes of how Java can run properly on an AS400 machines, because usually when people write code, it is usually in COBOL and RPGLE, but a Java code and a Java command can also be created. In further videos, we will try to explore how we can connect with the AS400 DB2 database from our Java program, and also read and write to the database. And we'll also try to research how we can display a screen or read from a screen and execute Java in the backend. That is it for today's video. If you do like these videos, kindly consider subscribing to the channel. Thank you for watching. Bye bye.